Good afternoon and welcome to NASA's Kennedy Space Center in Florida. We're just a few hours away from the expected move of the Orion spacecraft to its launch pad for the December flight test. And here to talk about the move, I'm pleased to be joined today by NASA Kennedy Space Center Director Bob Cabana, Johnson Space Center Director Ellen Ochoa, NASA Orion Program Manager Mark Geyer, and Lockheed Martin Orion Program Manager Mike Hawes. We'll begin with some opening remarks and then we'll be happy to take your questions. Mr. Cabana?
Thanks, Mike. Well, I'm sorry the weather didn't cooperate and we're not sitting out at the LASF with Orion in the background, but let me tell you, it really looks great, and hopefully the weather will cooperate and we'll roll over to the pad later this evening. I got to tell you, this is special. This is our first step on that journey to Mars, and to see the vehicle on top of the service module with the launch abort system attached, it's quite a stack, and it's going to look really good on top of that Delta IV as we go for that test flight on December 4th. You know, when it rolled out of the ONC high bay in the Neil Armstrong building there, you know, that was really special. That was the first time that a crewed vehicle has rolled out of that high base since Apollo-Soyuz test project back in 1975. And to see history being made, it was a special day. And that was an awesome partnership with the state of Florida and Lockheed Martin to make that facility a high bay, a processing facility, a manufacturing facility for the Orion spacecraft. And after all that hard work, you know, now we're seeing the results of it, and I can't be more excited about the transformation that we've made here at the Kennedy Space Center, supporting the Space Launch System, out at the pads, over in the VAB, the crawler transporter. Everything's tracking along to that FY-18 test flight with the big rocket on it. And this is a huge first step to be able to check out the vehicle on the Delta IV and get some data back, and we'll let Mark talk about that. But you know, between the transformation of Launchpad 39 to support the SLS, the commercial operations that we have going on, turning over the facilities to enable commercial space operations, awarding the contract for commercial crew, and then the great science missions that we have going on supported by LSP to procure those expendable rockets. I think our future here at the Kennedy Space Center is really being solidified, and it's a real pleasure to be here tonight to be able to see Orion roll for its first test flight. So thank you all for coming out today.
Orion represents the latest human-rated spacecraft that Johnson Space Center has had the privilege of developing, also including the International Space Station, the shuttle orbiter, and of course going back to Apollo. And we're the center that are eventually going to put our astronauts on board. So this initial test flight, which focuses on some of the highest risks to bringing the crew back safely from exploration missions, is really important to us. We work closely with our contractor partner, Lockheed Martin, not only through the program office at Johnson that Mark Geyer leads, but also in providing expertise and hardware and software. Our engineering organization provided the entire parachute system for Orion, and our engineers have also worked alongside Lockheed engineers on developing the guidance, navigation, and control systems. And Lockheed's making use of our experienced flight operations team for this test flight. So it's really a team effort, and that's also true across NASA. You've already heard from Bob about some of the work that's gone on here at Kennedy Space Center. There are several other NASA centers that are either supporting the flight directly, such as the spacecraft adapter provided by Marshall Space Flight Center, or that support the Orion program in other ways as we move toward future test flights and exploration missions. So people across NASA are involved in this first step toward pioneering space. And we're excited to have completed the test article for that mission, to see it roll out to the pad later tonight, and to finish preparations for the December 4th flight.
Well, let's see, a great picture. I wish it weren't quite so wet, but the main thing is we're looking forward to hopefully clear up by about 8:30 when we move out of there. And it's a great, you know, just to have been in the last Thursday, it's very impressive to be right up next to it. It's about 72 feet tall, and it shows really the three key pieces of Orion, the launch abort system on top, with its aerodynamic shape, then the crew module, which it covers, and then the service module below with the fairings now cover it too. So great hardware, great example of the hard work of about 3,000 people that support the Orion program. I talked a little bit last Thursday about Orion. Of course, Orion is the exploration spacecraft for NASA, and paired with SLS, will go explore the solar system. This particular test is unmanned, EFT-1, and we're going to test really, I would say, the riskiest parts of the mission in ascent and entry, things like the fairing separations, heat shield, parachutes, entry navigation and guidance, those kind of things. We'll test all those in this flight, as well as flying into deep space and examining the radiation effects on the avionics. So all those are happening as part of the flight, and tonight is just the next big milestone as we roll out and get stacked on the launch vehicle tomorrow.
It's always tough to be last. So, Mark alluded to the teams that have been working on this for a long time, both NASA, Lockheed, and all of our teammates on the industry side. This is a really proud moment to be ready to actually roll the spacecraft out and to mate it on top of the Delta IV Heavy, which is really a big moment for us. We've talked a little bit about this team, and it is a different type of operation. People get kind of clouded in this debate of old space, new space, traditional, entrepreneurial. This team is actually an interesting mix of many of those things, and you've heard it alluded to in a number of ways. Even though Lockheed was charged with the task of pulling together all the pieces for this test mission, Bob's team is doing the recovery and all the interface with the Navy in addition to their normal ground processing job. Ellen has talked about all the work that JSC did in line with the development, not just in oversight of the Lockheed and industry workforce. And then we have done not just all the design and manufacturing of the spacecraft itself, but Bob also mentioned the fact that we made a commitment several years ago to turn the ONC into a factory. And we have successfully done that to build this spacecraft. And that was, I think that was a big leap that lots of us saw back in that time. And it has worked, and we have Orion completed in front of us now. So I would add my hope to those that you've heard from already. Those of you that have seen Interstellar, we have folks actually talking about moving humans off of our home planet. And when we have those footprints on Mars, I certainly will believe, and I hope many of you believe, that this was that first step that got us started on that path.
All right, thank you. We'll be happy to take your questions now. Please wait for the microphone, state your name and affiliation, and to whom you're addressing your question. And we'll start with Jason.
Jason Ryan for SpaceflightInsider.com. I guess this question is either for Mark or Mike. You mentioned the factory over at the Neil A. Armstrong ONC building. When these test flights start taking place, you guys are going to be learning a lot of lessons about the heat shield, about the avionics on Orion. How soon do you think we could see changes that are learned from those lessons when you conduct these missions implemented into the next craft? Thank you.
Yeah, so
Today.
great question. Yeah, already. So for example, the barrel on EM1, the very next flight, the barrel, which is the barrel section for the pressurized element for EM1, is in manufacturing in Southern California today. And that barrel is 25% lighter than the one we're going to fly on EFT-1. So the flight itself into space is huge because we'll see how the systems operate in the environment, but actually building the first one is as big, right? How did it come together? When we got all the drawings and the cables laid out, how much did it weigh? What did we find out about when we did the loads testing, where we had margin? All those kind of things are huge even before you do the first flight. So we've already taken those lessons and rolled them into EM1 already. And then, of course, we'll get EFT1, we'll fly it, and we'll learn some more things, and we'll tweak some other things on the design. But that's a really good question because it's more than just the flight itself.
And we certainly learned a lot about the ONC as a factory.
Yeah.
What are the types of things that were problematic first flow through that we have an opportunity now to correct and do better on the next flows. So it's really, just getting here has been a huge learning experience.
Maybe a little more details on some of the changes you had to make to the ONC building to make it work with Orion?
It wasn't to the building per se, but to the layouts that we had in the building and how we were working in those work cells, using those Porta HEPA filter walls to keep down debris and stuff. We learned quite a bit about, particularly when we were doing welding inside the facility. You know, we will certainly be looking at making changes to that physical layout as we do the next build.
I think one of the things that's really neat about the way the ONC is laid out is none of that is a permanent fixture in the high bay. All of it is easily reconfigurable so they can get the best way, the optimum way to actually do the manufacturing and processing of the vehicle.
Rob.
Hi, Robert Perlman with CollectSpace.com. A question for Mark. Can you step us through, once Orion reaches the pad through launch, what else has to be done with Orion as you prepare it for the December 4th liftoff?
Yeah, so that there's a few things left to go. Orion by itself is done, but we're going to go stack it on the rocket, and so we'll test the kind of things you'd want to do on the rocket. So we'll test the interfaces, that they talk to one another okay, and then we'll actually do a test where we communicate with the TDRS satellites at the pad just to make sure that everything is still connected and everything still works. We'll do one more software upgrade, so we'll run that software in the flight element as well. And then we'll do a last pressure check after we put the hatch on for the final time. We'll make sure it's holding pressure, those kind of things. Those are the big tests we've got left to go. All those things we've done in the ONC, but we'll do it one more time when we're actually on the rocket.
For anyone who wants to take it, just by coincidence, 50 years ago this year, another new capsule was rolling out to the same pad, the first Apollo. And it was a boilerplate, but it still went out off 37B. And when we look back at that flight, we see that as the beginning of that adventure to the moon. If you can look ahead, maybe the 50 years ahead, how do you think we'll consider EFT-1? Will it be the same type of legacy, or will it be something bigger?
Well, I'll say a little bit because we've talked somewhat. We've kind of drawn the analogy before where, as people were preparing for Apollo, the Gemini missions were really important to understand how you do spacewalks and how you do rendezvous between two vehicles. And we see using Orion going forward in the what we call the exploration mission, EM1 and 2 and beyond, as sort of that same role toward eventually getting to Mars, where you're going to have to demonstrate various different kinds of capabilities, like doing deep space EVAs or doing automated rendezvous and docking, in the lunar vicinity. And so this is the first step toward doing that. And so that's part of our excitement, is we can see it building toward those kinds of missions.
And as Mark mentioned, even though we talk a lot about the heat shield on this mission, we're actually exercising a lot of the spacecraft on this mission. The guidance software, the thrusters, the whole, all the separation events, the reentry systems, the recovery systems. So it's actually a very large test of the system.
You're in the front row.
Hi, Eric Berger with the Houston Chronicle, and this is a question for Bob, Ellen, or Mark, whoever wants to take it. So we're almost 5 years now from February of 2010, when the president's budget came out and canceled the Constellation program. And I'm just wondering what it feels like to have sort of come from that low in terms of Orion and the different pieces of Constellation to sort of be here to actually be launching hardware in space, and does it make it sweeter, or just kind of what's your sense?
Well, from a KSC point of view, the team is motivated. They are really enthused about everything that's going on, and this flight's it's a big deal. It's good to be flying. It's good to have a path forward, but it's not just Orion and SLS. I mean, you got to tie it all together. It's commercial crew. It's everything. In 2017, we're going to have U.S. astronauts flying to the space station on a U.S. rocket, and that's huge. To have a path forward from an exploration point of view, to be able to even think about the asteroid retrieval mission and flying in vicinity of the moon in this lunar distant retrograde orbit on Orion to go visit an asteroid. I mean, that's pretty darn neat. That's exciting, and we're doing some really cool stuff. And I think the whole team is on board with it. They're enthused to help make it happen, and I think there's a genuine positive atmosphere, and I don't think it's confined just to KSC. I mean, you go across to all the NASA centers that are involved in this. I think the team is really looking forward to the future.
Yeah, I think there's these political questions are going to come up. They're going to come up about every change of president. People are going to step back and ask, what is the policy? What is our new plan? I don't expect that to change. It's been that way. It was that way for Space Station. It's happened to us. I think the key lesson for us is to persevere, continue to show the value of the program in any of these strategies that are discussed. And I think that's the thing I get out of that, is that this Orion design, this concept of a deep space exploration vehicle has survived those discussions, which were difficult, right? And very much pressing, what is the mission we have for this vehicle? And it survived that, and now we are here about to fly. So I think that says a lot about it's a good design, it's a good team, it's a good mission, and now it's time to fly it. So it is very exciting. It is a very exciting time for the team, absolutely.
James, Dean?
James Dean, Florida Today, and I was just curious about some of the logistics of the rollout and your weather constraints. Are there any significant constraints to getting out, hopefully close to on time, and pretty long, maybe a little bit circuitous route? I was just curious the reason for that, and but given that you're going by Pad B, I guess, is in appearance, is this exactly how it will look when you're rolling out to an SLS?
Let's see, how about, I'll take a couple of it. First off, the reason we're going by Pad B and not more directly by Pad A is we got an issue with the road out there, and it wouldn't support the vehicle. And we're doing some repairs on the bypass road around Pad A, so that would have been a more direct route. So we have to go around and use the road by Pad B in order to get out to 37. So that's one of the reasons we're going by Pad B. Will it look exactly like this when it rolls out? No, James, we're going to be on top of the SLS on the mobile launcher, and it's going to be awesome. But as far as what gets stacked on top of the SLS, yeah, this is, when it goes by Pad B, this is what is going to be on top of the SLS. This is what it will look like. And so that's pretty cool. So maybe we'll get a few pictures of it, weather permitting and lighting and everything else as it rolls past its future launch site on its next mission. So that's going to be pretty cool. But it's as far as weather, we talked about that right before we came out here too. We're going to get a further weather forecast here in about 40 minutes, and then we'll know whether we are within the constraints or not. But it's primarily you can't have wind gusts over 25 knots. We're looking at 20 knot wind restraint, and you can't have be in a phase 1 lightning hold, both for the vehicle and the people that are going to be going with it. So, I think we're looking at maybe not rolling out quite on time, but we'll have to see. We'll see what the weather forecast is, and hopefully we'll get out there. It's about what do we got, about a 6-hour roll to the pad, roughly?
Yep.
So we got some time to get there tonight.
Yeah, initial reports were that it may take a couple hours for the system to move through, and we'll see that the team's meeting here, like Bob said, in half an hour, 40 minutes or so to make that determination of what the timing will be.
Amy Green of WMFE Public Radio. We know that the ultimate mission of this spacecraft is to go to Mars. What is the time frame at this point for the first manned mission with this spacecraft, and what would be the nature of that first manned mission?
The first manned mission would be 2021. Before that, so we'll fly EFT-1, then we have the next flight is called EM-1, which will be another unmanned flight. That flight would be on a full service module and on the big rocket on SLS. So that's about 2017, 2018. 2021 will be the manned launch. Right now we're looking at the specific objectives of that. It depends on how EM-1 goes. EM-1 today we're going to send around the moon and do some complex orbital maneuvers to kind of test out those plans. If that goes well, we could either leave EM2 around the Earth, or we could send it out past the moon. So it'd really be the fundamental test for EM2 is to put people in the vehicle and make sure all the life support and all the things that interact with the crew are working correctly, and then push the other systems as much as we can, depending on how EM1 went. And then after that, we're looking at this asteroid retrieval mission, when the next flight is for that. Once we do EM2, fundamentally, we've already got the fundamental systems for us to on the manned side to do the mission. We've got the airlock with the cabin of Orion. We've got suits. We've got guidance navigation. We've got all those kind of things. So that after EM2, in that range, a flight or two, is when we'll do the asteroid visit mission.
Okay, if you're on the phone bridge and you have a question, please make sure to unmute yourself, and we'll take a question here from Jason.
Jason Ryan, Spaceflight Insider. This is kind of follow-up to the last question. Orion, if memory serves, is capable of supporting a crew of 4 to 6 for 21 days, and it's been posited that a spacecraft for a Mars mission would be equal to or larger than the space station. So my question is, where is NASA in its development of this spacecraft, and is it possible we're looking at another international collaborative effort on the road to Mars?
Well, I guess there's a number of things you can say there. First of all, Orion already is an international effort, because on EM1, ESA will be providing the service module. So, the program has already taken that first step to bring in international partners, and yes, we absolutely, that would continue not only with ESA, but we hope with other international partners as well. And on the way to Mars, what we would assume is that we have some sort of habitation module, which will be the module that would keep crew alive for the long transit back. And the Orion is really what gets you into space, and really importantly, gets you back at the end of the mission from the high speeds that you would be coming back. One of the reasons the asteroid retrieval mission is a good step toward that is because we can carry out that mission with Orion and with SLS in their initial configuration without developing a HAB module or any other sort of major module. We can do it with their initial configurations.
Okay, let's go to the phone bridge and take a question from Mike Wall, space.com, and then we'll come back here to Kennedy. Mike?
Okay, thanks, guys. Yeah, this was just for the entire panel, I suppose, whoever wants to actually take it. So it's been 42 years since people have been in deep space, and so I guess, yeah, what were the major challenges toward developing a brand new spacecraft that can take people to deep space, and yeah, what are some of the major things you guys are actually looking to find out during this first test flight? I mean, I know you guys talked about all the systems that you're going to be checking, but are there one or two in particular things that you're really curious to see on this first flight? And they can just briefly talk about how that relates to actually building the first deep spaceship for people in about 4 decades.
Sounds like yours.
Yeah, there's a lot of things. Yeah, excellent question. There's a lot of things about a vehicle that goes to deep space that are different than a vehicle that orbits at low altitudes, like at space station altitudes. Some of the big things are consumables. You go 21 days, you got to take a lot of oxygen, water, food, those kind of things, CO2 removal, those kind of things. So that can drive the size. It also drove for us a technology for removing CO2 that did not require these lyo cans. You remember the shuttle used to take a bunch of those, and when you're out for 21 days, that's a big mass hit. So we developed a new technology to do that. Another thing about a deep space vehicle is you're a long way from home if something happens. If you're in low Earth orbit, you can get to the ground in about 45 minutes. If you're out past the moon, you're 5 to 12 days away from home, depending on the mission we're looking at. That's a long way. So you've got to have highly reliable systems, and you've got to have capabilities to protect the crew in case of a contingency. So one of the examples that we talk about is we can support the crew in their suits for up to 6 days. So if we have a totally depressed cabin, they can be in their suits and we can get them home. That's an example of a deep space spacecraft and the kind of complexity you have to add to make that work. Ellen also mentioned the speeds coming back from the moon are higher, so the heat shield has to be different materials, different different thicknesses, other things you have to consider. And actually the physics of entry changes when you come back at those higher speeds. So those are all the kind of things you have to think about. On this particular flight, and also radiation. Radiation, once you get past low Earth orbit, is significantly higher. And so for the crew, if the mission's in 21 days, it's not a big driver for the crew, but it can affect your computers. You know, our computers now, the circuits are so small, they're actually affected much more by radiation. And so you have to be able to handle things we call like upsets, where the computer decides to glitch and you have to reset it. You have to handle in your redundancy and backup systems available to restart and not lose your state of the vehicle, the nav state, those kind of things. So all those have to be accounted for in your design. On this particular flight, we're going to test things like the heat shield. That's one of the big things about the test. So that's why we're going. Using the Delta IV Heavy gets us, 15 times higher than space stations, about 84% of a lunar entry velocity. So we start seeing that different physics. We start seeing those very high temperatures, high velocity. So that's one of the big things we'll test. And as we go through the Van Allen belts, we're going to see this radiation effect on the computers. So we're both going to measure with dosimeters. We're going to measure the environment. We're also going to see how the avionics behave, which is actually more important. And how do our mitigations work? How did it work with the resets that we put in the plan? So those are the kind of things I would say. All the things that are normally tricky about entry, like the parachutes deploying. We have a lot of parachutes because you need to slow the vehicle down from about 300 miles an hour to 20 miles an hour. And so we do that in stages. Parachutes are the only system that actually assembles itself in operation. They come out and the parachutes interact with one another. You might see that almost like they're breathing. So you need to know how that works, because that affects the loads on the crew, affects the loads on the spacecraft. We've done a lot of drop tests out in Yuma and looked at failure cases, but until you actually drop it in the exact air density and speeds that you're going to see, we're certainly going to learn some stuff from that. So I'd say those are the biggies.
Well, and I would say just from technology standpoint, people make a lot of comparisons to Orion or to Apollo because it looks similar. And in fact, the shape is the best shape for coming in from that high-speed type reentry. And the AVCO material, which we're using on heat shield, is similar to the AVCO used for Apollo, although we have had to make some changes due to materials changes. But the technology of just about everything else that we use to put in Orion and to build Orion have changed dramatically in that time. You think of 50 years of manufacturing changes, and it's a totally different world. And in fact, we do have additive manufactured parts on Orion today.
Okay, we're back here at Kennedy, and time for one last question.
Hi, Jared Hayworth with Spaceflight Insider. Question for Bob. Orion's leaving your property for the first time in over 2 years today. Can you tell us a little bit more about what Kennedy's role is going to be once it's out there at the Canaveral side? What's going to happen here with facilities and people to support the mission?
Sure. Well, this is a Lockheed Martin test flight. The program is getting all the data from Lockheed Martin. We will do flight following, our launch services program. We'll have folks over in Hangar AE watching the data, just as any expendable launch vehicle that we launch. We're in an advisory role. We're not actually responsible. We'll have folks in the LCC also following the data. Ellen's folks in Mission Control in Houston are going to be following it. And then the next really big role that we play is going to be the recovery of the vehicle off of Baja when it lands off the coast of California, and then working with the Navy to bring it back here. And we're looking forward to getting it back so we can process it for that abort flight down the road.
There's a lot of work to be done. Bob's team is doing the transport cross country from the port to get it back here. We hope to be back in the ONC Christmas week-ish. But there's a lot of work to be done, because really gathering not just the data, but really starting to pull the back shells off, look at the systems, understand how they really weathered the flight. There's a huge amount of work to be done with that.
All right. Thank you all very much for coming. We look forward to tonight's move. You can keep track of the status of the move on the NASA website at www.nasa.gov/Orion and on social media using hashtags Orion and I'm on board. Thank you again.